Hi, this is Jayanti. Today I am here to discuss about the parameters of transmission line. Already I have discussed on the last session how to calculate the inductance for single phase transmission line. But on the last session I have considered there the solid round conductor. But in actual practice, the transmission line conductor may be of stranded type. This stranded conductor actually is used to reduce the skin effect, and as this stranded conductor is composed of number of parallel conductors, number of conductors connected in parallel, that's why it may be called the composite conductor. This conductor, the conductor for transmission line may be of stranded copper or hollow copper conductor, or it may be ACSR. ACSR, which one is very popular and which one is used very much in today's power system transmission line. ACSR. What's the full form of ACSR? That one is nothing but aluminium conductor, aluminium conductor, steel reinforced. Aluminum conductor, steel reinforced. And what's the advantage of this ACSR over the copper conductor? It's cheaper compared to the copper conductor having the equal resistance, and it's having the greater mechanical strength. Just see here how the strands are aligning here. Inside there, the strands are of steel, and the red color, the strands marked by red color is of steel, and the strands marked by blue color is of aluminium. The strands marked by blue color is of aluminium, just like that. Just like that. So the inside the strands marked by red color is of steel, and outside the strands marked by blue color is of aluminium. And it's mainly used for high voltage line, extra high voltage line. Next, consider here the inductance of composite conductor. The inductance of composite conductor, let's assume here there are the one is the incoming conductor or the forward conductor, and another one is the return conductor. Both of them are of composite type. Suppose to say this one is composite conductor X. This one is composite conductor X carrying current plus I, suppose to say. And this composite conductor is having n number of, this composite conductor is consisting of n number of stranded conductors. If all the subconductors are carrying equal current, then each subconductor, the current flowing through each subconductor will be plus I by n. Now let's consider here another conductor, that is the return conductor for it. That one is also the composite conductor having m number of strands, having m number of strands there, and current flowing through this composite conductor is minus I, obviously under balanced condition. And if all the conductors, all the subconductors are carrying equal current for this composite conductor Y, then the current flowing through these return strands will be minus I by n. Minus I by n, because there are m number of strands, So the flux linkage of subconductor A So the flux linkage of subconductor A can be written as just like that. Lambda equals to, already we have derived the generalized expression on the last session. That is lambda I equals to 0.4605 II into LII plus summation or integration of the mutual component. That's why I have written that one. That is the total flux linkage for subconductor A, 0.4605 I by N. That is the sulfur log 1 by Rx dash, because here we have assumed here the radius for each subconductor for composite conductor can be written as Rx. Here it can be written as the radius for each subconductor can be written as Rx, while the radius for each subconductor can be written as Ry. So it can be written as 0.4605 into I by N log 1 by Rx dash plus log 1 by DAB. DAB is nothing but the distance between the center of two conductors for composite conductor X, plus log 1 by DAC plus log 1 by DAD plus dotted plus log 1 by DN. Next one is the mutual part. That is minus 0.4605 I by N minus 0.4605 I by N, because here each subconductor is carrying current I by N, minus I by N. That's why I have taken here minus 0.4605 I by N log 1 by DAA dash. Supposed to say these subconductors can be written as A dash, B dash, C dash, D dash, E dash, like that. Then it can be written as 0.4605 minus 0.4605 I by N log 1 by DAA dash plus log 1 by DAB dash plus log 1 by DAC dash plus log 1 by DAD dash plus dotted plus log 1 by DAM dash. This one I have got from the expression found on the last session. That one was the generalized expression. So here the flux linkage can be written as 0.4605 I into log DAA dash, DAB dash, DAC dash, dotted DM to the power 1 by N divided by Rx dash DAB product of all the distances, including the radius of conductor, fictitious radius of subconductor A to the power 1 by N. So what's the expression for inductance of subconductor A? It can be written as LA equals to lambda A by I, because we know flux linkage equals to inductance into current. It can be written as LA equals to lambda A divided by I. That will be 0.4605 log. Numerator, there will be the mutual distances, product of all the mutual distances to the power 1 by N. And in denominator, there will be the product of all the self distances or distance between strand A with the other subconductors or the strands of the self composite conductor, and the fictitious radius of the strand A to the power 1 by N. So the average inductance of any one subconductor, of composite conductor X can be written as summation of all the inductances divided by N. Summation of all the inductances divided by N. Now see, as all the inductances, all the strands are connected in parallel. All the strands of subconductors are connected in parallel. So the total inductance of the composite conductor X can be written as Lx equals to L average by N, which one is nothing but summation of all the inductances, summation of all the inductances of the conductors consisting in composite conductor X divided by N square. Where in generalized expression Lx can be written as 0.4605 log dm by dsx, just by putting here the terms for LA, LB, LC, etc., etc., we will have the generalized expression for ALX as 0.4605 log dm by dsx, dm by dsx, where dm is nothing but, this one is the mn root of the product of mn terms. Product of mn terms means it's nothing but the product of the distances between each subconductor, between the possible distances, possible distances between each subconductor of conductor X to all the subconductors of conductor Y. That one is dm, which one is also called geometric mean distance, that is mutual geometric mean distance, mutual GMD. Mutual dm is also called mutual GMD. This one is called mutual geometric mean distance or mutual GMD or mutual GMD. And another term there is, that is DSX. Which one is self? DSX. This one is nothing but the n square root. This one is nothing but the n square root of the product of n into n term, product of n into n term. That is nothing but the product of distances. That is nothing but the product of distances for in between the each subconductor to all the subconductors of the self-composite conductor. Suppose to say we are considering here composite conductor X. Then the first portion is nothing but the distance between the subconductor A to all other subconductors in the composite conductor X, including the radius or multiplied with the radius of subconductor A. That is DAA, denoted here as DA, which one is actually Rx dash. And this product is happening for all the strands. That is, there is another strands DBA, DBB, DBC, daughter DBN, just like that. This one is called the self geometric mean distance. This DSX is called self geometric mean distance. Yeah, the fictitious radius of each strands for the composite conductor AX actually represented in this generalized expression as DA, DPB, DNN. And the same thing may be written for composite conductor Y also, where for composite conductor Y also the same thing can be written as where dm will not be changed, for composite conductor Y. For composite conductor Y, dm will remain same. Same as before. What will be changed for DSY? What will be changed for DSY? There will be change for DSY just like that. It will be DAA dash, DA dash B dash, DA dash C dash dot dot. We have considered here m number of strands. Same thing will be happening for all the strands of composite conductor Y, and the last product will be MA dash, MB dash. It will be DMN. And here the root will be m square root. there will be the product of the term m into m, and it will be the root of 1 by m square. Only there will be the difference in between the cell portion, but mutual portion will be same as before, and it's all about today's session. Thank you.